Okay, in this video series, we'll be looking at matrices. So, a matrix is a set of numbers arranged in rows and columns so as to form a rectangular array. The numbers are called the elements or the entries of the matrix. So, if I have something like 2, 3, 1, 1, 5, 4, this is a matrix. If you have something like 2, 5, this is a matrix. If you have something like 1 minus 1, 0, 0, 1 minus 1, 1, 1, 1 is also a matrix. Okay? So, and each of these numbers here are called the elements of the matrix. Okay? So that leads us to order of a matrix. The order of a matrix represents the number of rows and columns in that matrix. So if I have a matrix like A, B, C, D, E, F, this matrix is a 2 by 3 matrix. 2 by 3 because it has 2 rows. This is row 1, this is row 1, row 1. Excuse me, this is row 1. Then this is row 2. It has 2 rows, but it has 3 columns. Column 1, column 2, column 3. Okay? If I have something like this, A, B, C, D, this is a 2 by 2 matrix. It has 2 rows, R1 and R2, and it has 2 columns, C1 and C2. Okay, if I have something like this, 1, 3, 5, this kind of matrix will be 3 by 1 matrix. Why? It has 3 rows, 1, 2, 3. Okay, row 1, row 2, row 3, but has only 1 column. Okay, so 3 by 1 matrix. That is the order. That is what we call order of a matrix. Now there's this a square matrix. A square matrix is one with equal number of rows and columns. So a good example of square matrix, we have 2 by 2 matrix, we have 3 by 3 matrix. They are square matrix. The number of rows is equal to number of columns. Example of 2 by 2 is A, B, C, D. Example of 3 by 3, we can have A, B, C, D, E, F, G, H, I. Okay, that's a 3 by 3 matrix. Okay, we'll move on. Now the next is an identity matrix. Identity matrix is a square matrix which contains the value of 1 in its diagonal and the rest are 0. And for example, a square matrix, if I use 2 by 2, now a 2 by 2 matrix, the diagonal is 1, okay, while the rest is 0. So this is an identity matrix for a 2 by 2 matrix. Okay, but if it is for 3 by 3 matrix, if it's a 3 by 3 matrix, the diagonal is 1, 1, 1, 1, the rest is 0, 0, 0, 0, 0, 0, like this. Now, what is the significance of identity matrix? Now, look at this. It says if I is an identity matrix, then for a matrix A, AI must be equal to IA equal to A. Okay, that means any matrix you multiply with identity matrix will still give you that same matrix. Like in our normal counting numbers, identity is 1. So any number you multiply by 1 still gives you that same number. If I say 5 times 1 is still 5. If I say 100 times 1 is still 100. That's identity. So that's the same with identity matrix. When you multiply a matrix with an identity matrix, you will get the matrix itself. Okay. So we have scalar multiplication of a matrix. The scalar multiplication of a matrix actually has to do with multiplying a matrix with a scalar. Matrix is actually a vector. Okay, it can be represented as a vector. So according to scalar matrix, if I have k, a, b, c, d, the value k multiplies all the elements in the matrix. We are going to have ka, kb, kc, and kd. Okay, so if I have something like this, 3 into 2, 1, 5, 7, it means 3 multiplies everything in the matrix. 3 times 2, that means it's going to be something like this: 3 times 2, 3 times 1, 3 times 5, and 3 times 7. Okay, so that will now give us 6, 3, 15, 21. Okay, good. So it means that if I now have something like 5 into minus 1, 0, 2, 3, that's going to be equal to 5 multiplying everything. I'm going to get minus 5 here, get 0 here, get 10 here, and get 15. This is beautiful. Okay, that is it for scalar multiplication. Let's move on. Now we have addition and subtraction of a matrix. Okay, before I continue, I would like to say that for two matrices to be able to add or subtract, they must have the same order. Their order must be the same. That means 2 by 2, we can only add 2 by 2. 3 by 3 can only add 3 by 3. 2 by 3 can only add 2 by 3, and so on. Now, the next is that in addition of matrix, the corresponding element we add to the corresponding, an element we add to the corresponding element in the other matrix. For example, look at these two examples here. Here now we can see that 2 can only add to 3. And 2 plus 3 here will give me 5. Minus 1 can only add to 10. They're on the same side, okay? Minus 1 plus 10 is 9. 3 here can only add to minus 12. 3 plus minus 12 will give us minus 9. Okay, then finally 5 here can only add to 4. 5 plus 4 will give us 9, okay? So this is what we get, okay? So look at the next matrix here. We have 2, number 2, we have 2 plus 0. Okay, minus 2 minus 0 here will give us 2. We have 3 minus 6 will give us 3 minus 6 will give us minus 3. Then we have minus 2. Minus 5 means plus 5, okay? Then minus 2 plus 5 is 3. We have 9 minus 1. 9 minus 1 is 8. Then we have 1 minus 13. 1 minus 13 is minus 12. Then we have 0 minus 10. That means 0 plus 10. That will give us 10. Okay, so this is what we get in addition of matrix. Now let's move further. Okay, look at this question now. We're asked to find the value of x and y represented if the matrix, this matrix here, plus this matrix equal to this matrix. And that's very simple. So let's look for the corresponding element. Here you see we have 1 here, no 1 here, we have x here, and we have minus 2. So let's say that means 1 plus x is equal to minus 2 from the question. So you can see that x will be minus 2 minus 1, that means minus 3. The same with y. Let's say the corresponding elements, 2y and minus 3. That means 2 plus y equal to minus 3. So y now will be minus 3 minus 2. That will give us what? Minus 5. So that means my x and y are minus 3 and minus 5. So the answer is D. Okay? Beautiful. Now look at another question here. If P equal to 5321 and Q equal to 4235, we asked to find 2P plus Q. 2P plus Q, okay? 2P plus Q will mean 2 into 5321 plus Q. Q will be 4235, okay? So 2 times the whole of that will give us 10, 6, 4, 2, okay? Plus 4235. So when you add corresponding element, 10 plus 4 will give us 14, 6 plus 2 will give us 8, 4 plus 3 will give us 7, 2 plus 5 will give us 7, okay? That is beautiful. That becomes our answer, 14877, 14877, so the answer is B. Wow, this is beautiful. Okay, so let's move on. Now, that leads us to multiplication of a matrix. Now, before we continue with multiplication of a matrix, I would like to note 2 things. Number 1 is that for 2 matrices to multiply each other, the number of elements in the rows of the first matrix must be equal to the number of elements in the column of the second matrix. Why? Because in multiplication, we multiply row with column. That means we multiply row. This is a row. This is column. Okay? So, now, let's start with first row and first column. First row multiplying the first column. That means row 1 times column 1. Okay? So, that is exactly what we are going to have. Your answer is going to be the row 1. We're going to have 1 will multiply minus 1, which is in column 1, then plus 3 will multiply 2. See that? That's for the first aspect. Now let me rub this off. This starts the new note. So we have we say 1 multiplies minus 1, then plus 3 multiplies 2. Okay, so the next one is the same row 1. That row 1, which is 1 and 3, with column 2 of the next matrix, which is 5 and 1. So row 1, that means 1 will multiply 5, plus 3 will multiply 1. You see that? Okay. So now we go with row 2. Row 2 and column 1. Row 2 of the first matrix with column 1 of the second matrix. We are going to have 4 into minus 1. Okay. 4 is from row 1. Minus 1 is from column 1. Then plus, we have minus 2 into 2. Okay. Then we come over here. We have, that's row 2 of the first matrix, column 2 of the second matrix. That's going to be 4 into 5. Okay, then minus 2 into 1. Good. So that's the matrix. Now, if we open that up, here, 1 times minus 1 is minus 1 plus 3 times 2. That will give me 5 in total. Then 1 times 5 is 5 plus 3 times 1 is 3. That's 8. Here, 4 times minus 1 is minus 4. Minus 4 plus 4 is 0. Then here, 4 times 5 is 20. 20 minus 2 is 18. So that is what we get here. Okay? So that is the answer we get for multiplying the two matrices. Let's try the second one. Let's try the second one. Okay? Now for the second one, we have 3 rows in the first matrix. Row 1, row 2, and row 3. Okay? By the next matrix, we have 2 columns. Column 1 and column 2. But remember, you're multiplying row to column, row to column, row to column. So we start. So the first one is row 1 in the first matrix, column 1 in the second matrix. That will give us 2 times 2 plus 4 times 4. Okay. Then we move row 1 now. That same row 1 and column 2. That's going to give us 2 times minus 5. Okay. 2 times minus 5, then plus 4 times 3. So now row 2, that's 1 and 7, we multiply column 1 of the next matrix, 2 and 4. That means 1 will multiply 2, then plus 7 will multiply 4. Okay, then that same row 2, multiply the next column. That means 1 and minus 5 will multiply plus 7 times 3. Okay, please observe the pattern. Then the last row with the row 3, minus 3, 0. With column 1, that means minus 3, 2, plus 0, 4. Okay? Then that same row 3 with column 2 will give us minus 3, minus 5. Okay? Then plus 0, 3. Okay, so if we multiply that, the first one here, 2 times 2, 4 plus 4, that's 20. The next one, minus 10 plus 12, that's minus 2. Minus 10 plus 12 is minus 2. Okay, this is 2 plus 28, that's 30. Minus 5 plus 21, that's 16. 3 times minus 2 is minus 6. So minus 6 plus 0, that's minus 6 here. And finally here we have 15. Good. So that's the answer we get for multiplying the two matrices. So remember, multiplication of matrix is always row to column, row to column, row multiplying column. Okay, so we'll move to the next. Okay, look at this. We have 3 by 3 matrix. Okay, so remember your multiplication is row and column. So let's start with row 1. So row 1 now will multiply column 1, that's column 1, column 2, and column 3. You see that? Of the next matrix. So what is row 1? 2 minus 2, 3. So let's see, row 1 with column 1, that means 2 into 0 minus 2 into 2, then plus 3 into minus 9. You see? That's row 1 multiplying column 1 of the next matrix. Then row 1 multiplying column 2 of the next matrix will give us 2 into 2, okay, minus 2 into 1, okay, then plus 3 into 2. That's row 1 and column 2. Then the next one will be row 1 again and column 3. That will be 2 into 0. There's no space here. Okay, let's see. 2 into 0 and minus 2 into 7. 2 into 7, okay, then plus 3 into 1. Let's manage that. Okay, so now we pick the row 2, the second row. So the row 2 will multiply column 1, column 2, column 3 of the next matrix. So that will be 1 into the first column, 0, okay, plus 1 into 2, plus 1 into minus 9. That's second row and first column. Then that same second row, 1, 1, 1, and the second column of the next matrix, 1 is into 2, plus 1 into 1, plus 1 into 2. Okay. Then that same second row with the first, so that will be 1 into 0, plus 1 into 7. Then plus 1 into 1. Okay, so finally we pick the third row, R3 now for here, and multiply both column 1, column 2, column 3. So we are going to have 6 into 0 here, minus 3 is 0, minus 0, so minus 3 into first column 2, then plus 1 into minus 9. Okay, that same row 3 with the second column now will give us 6 into 2 minus 3 into 1 plus 1 into 2. Okay, so we're going to have row 3 column 3 will give us 6 into 0 minus 3 into 7, then plus 1 into 1. Okay, so if we are to combine all of this, what do we have? So multiplication, the first row, first column multiplication is 0 minus 4 minus 36, that's minus 40 here. Okay, the next one here, row 1 column 2, that's 4 minus 2, 2, 2 plus 6, that's 8. The other one is 0 minus 14 plus 3, that's minus 11 here. Then row 2 column 1 will give us 0 plus 2 minus 9, that's minus 7. We have 2 plus 1 plus 2, that's 5. Here we have 0 plus 7 plus 1, we have 8 here. Here 0 minus 6 minus 6 minus 9 minus 15. Yeah. Here is 12 minus 3, 9, 9 plus 2, 11. Yeah, 0 minus 21 minus 21 plus 1 minus 20. Good, so that is the answer we get. Wow, look at this. We have to find P and Q if the matrix 2P 8, 3 minus 5Q times 1 over 2 is equal to 24, 7. Okay. Now here is a matrix actually. It should be written as 2P 8, 3 minus 5Q. Then into 1, 2, then equal to 24 minus 17. So here this row can multiply, sorry, there should be no 1 over 2, 1, 2. Okay, so we multiply row with column, you see. So we have only one column in the second matrix. So 2p and 8 multiplies 1 and 2. That means 2p times 1 plus 8 times 2. And on the left hand side is equal to 24. You see that? So 2p times 1 is 2p plus 8 times 2 is 16 equal to 24. 2p will be equal to 8. That means p equal to 4. So p is 4. Okay? And p is 4. Good. Now let me find q. To find q, I'll multiply the second row of the first matrix with the column of the second matrix. That means 3 times 1 row. Okay, then minus 5q times 2 equal to, on the right hand side is minus 17. That should be the answer. So that means 3 minus 10q is equal to minus 17. Sorry, minus 17. So minus 10q is equal to minus 20. That means q will be equal to 2. So your p is 4, your q is 2. P, q. So the answer is C. Beautiful, beautiful, beautiful. Wow. Okay, so here we look at determinant of a matrix. So the determinant is defined as a scalar value which is associated with a square matrix. That means the scalar value associated with the square matrix is determinant. If X is a matrix, then the determinant of a matrix is represented by X, or determinant of X. So we see for a 2 by 2 matrix here, the determinant is A times D diagonal minus B times C in the other diagonal. So AD minus BC, that's what we have there. Okay, so if I have A, B, C, D again, I multiply A times D, then minus B times C. That means AD minus BC. That's for 2 by 2 matrix. Now, but if we are dealing with a 3 by 3 matrix, what we'll do is we start with the first row. We give sign plus, minus, and plus. And we eliminate, we pick each of them. When we pick A, just like we have here, eliminate all the elements under A in the same column and in the same row. All the elements in the same column, that means A. I eliminate this, I eliminate this. What do we have left? We have E, F, H, I. That's what we have here, E, F, H, I. Then minus B. When we pick minus B, eliminate all the elements in B in the same row with B and in the same column. So all the elements in the same row, all the elements in the same column, you see? So what do we have left? D, F, G, I. That's exactly what we have here. Then for C plus C, if I do the same, eliminating elements in the same column, in the same row, what do I have left? It's going to be D, E, G, H. That's exactly what we have here. D, E, G, H. Those are 2 by 2 matrix, which we can now find EI minus FH and so on and so forth. Okay, so that is how to find determinant of a 2 by 2 and a 3 by 3 matrix. So let's see. Now we have to evaluate determinant of this. We are given 2, 3, 4, 10. Okay, so determinant now will be 2 times 10 minus 3 times 4. Okay, so 2 times 10, then minus 3 times 4. So 2 times 10 is going to be 20, minus 3 times 4 is 12. That will give us 8. So the determinant of the matrix is 8. Okay, so here is a 3 by 3 matrix. Oh, okay, so we are taking the first row, that's plus, minus, plus. Remember, always remember that plus, minus, plus. So if I take 2 as an element, if I eliminate elements in the same column with 2 and in the same row with 2, what do I have? I have what left? 0, 1, 5, 2. That matrix left. Then we have minus 1, minus 1. Okay, eliminate elements in the same row and column with 1, eliminate this, eliminate this. So So what do I have left? I have minus 3, 1, 5, and 2. Okay. Then also the next one now is 5. That means plus 5. Eliminate elements in the same column and row with 5. Okay. So what do I have left? Minus 3, 0, 5, 5. Okay. Now this will now be equal to 2 times. Here 0 times 2 minus this. That's 0 minus 5. Okay. Then minus 1 into minus 3 times 2 is minus 6. Then minus 5 times 1 is 5. And here plus 5 minus 3 times 5 is minus 15. Minus 0 times 5 is 0. So this will now be 2 into minus 5. Then minus 1 into minus 11. Then plus 5 into minus 15. So that will be minus 10 plus 11 minus 75. So that will be 1 minus 75. That will be minus 74 as the answer to that question. Okay, minus 74. So let's move on. Now look at this. The determinant of this matrix is equal to 23. We have to find k. We have to find k. So let's start with plus minus plus like we have. So if I pick minus 2, if I eliminate the row and column of minus 2, I will get 1k 3 minus 1, right? Then I have minus 1 again. If I eliminate the row and column, I will have 2k 1 minus 1, okay? And finally plus 1. If I eliminate row and column, 1 plus 1, I will have 2, 1, 1, 3. So this will now be minus 2 into 1 times minus 1 is minus 1 minus k times 3 is 3k. So that means minus 3k. Minus 3k. Okay, then we have minus 1. Remember, everything is equal to 23. We have minus 1 into 2 times minus 1 is minus 2 minus k times 1 is k. Okay, then plus 1. 2 times 3 is 6. Minus 1 times 1 is 1. Remember, everything is equal to 23. So this will now be 2 into minus 2 into, okay, I guess we should open the bracket now. Minus 2 times 1, minus 1 is 2. Minus 2 times minus 3k is plus 6k. Minus 1 times minus 2 is plus 2. And plus, then we have plus k. 1 times 6 minus 1, 6 minus 1 is 5, it will be plus 5, everything equal to 23. If we collect like times 2, 2 plus 5 will give us 9, 6k plus k will give us 7k. Everything is equal to 23. So we are going to have 7k to be equal to 23 minus 9. That will give us 14. So k is equal to 2. So the answer is B. Yeah. K is 2. Yeah, beautiful maths. Okay, so that leads us to the next. Yeah, it says a singular matrix. About singular matrix. Singular matrix is a square matrix whose determinant is 0. It is a matrix that does not have a multiplicative inverse. Okay, so here you have 5, 15, 2, 6. 5 times 6 is 30. Minus 15 times 2 is also 30. So that would get 0 as a singular matrix. Just a question here. Find x of the matrix below if the matrix is singular. For this matrix to be singular, it means that the determinant is equal to 0. That means we can say 2, 2, minus 1, 3, 4, minus 2, 1, x, 5. Determinant here is equal to 0. So we're going to get big start with 2. To eliminate the row and column, we're going to have 4x minus 2, 5. Then we have 3 here. That's minus 3 is plus minus plus. If you eliminate the row and column under 3, what do we have? We have 2x minus 1 and 5. Then finally we have plus 1 here. Eliminate the row and column. We are having 2, 4 minus 1 minus 2. So this is going to be 2 into 4 times 5 is 20 minus x times 2 is minus 2x. That means minus 2x. Then we have minus 3 into 2 times 5 here is 10 minus x times minus 1 is another minus x. So minus x minus minus. And plus 1 into 2 times minus 2 is minus 2. Then minus 4 times minus 1 is minus 4. Okay. So this will now be 2 into 20 plus 2x, then minus 3 into 10 plus x, then plus 1 into minus 2 plus 2. Remember, everything is 0 since it's a singular matrix. Let's find something to rub over here. If we open the bracket, we're going to get 14 plus 4x minus 30 minus 3x minus 2 plus, here is minus 2 plus 4, sorry, and that's 2, so that's plus 2, everything equal to 0. If I collect like times 40 minus 30 is 10, 10 plus 2 is 12. Here 4x minus 3x is x, all equal to 0. So it means that my x is minus 12. Okay, so this will come to the end of this video. We'll continue in our next class. Thank you.